This is EE449 Electronic Design Lab. Join with me is Ryan. My name is Cameron. Our circuit here, we have the ultrasonic sound sensor that this lab has as a final assignment. And what we can see here on our pre-captured oscilloscope capture is the triggering of the monostable 555 timer from essentially as a one-shot to trigger the switch to pass the crystal oscillator 40 kilohertz signal through, and we're getting this weird noise here propagated through the ground is what we're assuming, and at some distance we get the traveling waves interfering with each other from the perspective of the receive amplifier, which was in green, and in yellow is what the Arduino is feeding into the 555 timer.
Or into the gate driver through that pulse from the 555.
Okay.
Yeah.
So can you unpause it?
We run this. We still have that noise, we assume, from the gate driver propagating through the ground into our receive amplifier's signal. And there is that noisy baseline. But as we move over our sensor, we can see that it's reaching the rails from the amplified received signal. And if we raise it up, we can see that it slowly shifts further delayed away from that initial pulse. And then if we remove it entirely, then we just have that noise in the background.
It's also worth pointing out that this is powered by a 9 volt to 0 volt power supply, so theoretically it should work on a 9 volt battery for a limited amount of time. Unfortunately though, we can't get the Arduino to give us solid values due to its processing speed or some other misconception with the Arduino that we cannot get accurate end-to-end measurements. But on the oscilloscope, we can get accurate measurements when we see the pulse from the PLL's perspective.
So switching to the PLL, we do see, we can grab that there.
Because I know the voltage like decreases when the signal is sent in pulses.
If I single pulse it,
By how much?
yeah, okay. We can see the triggering low of the PLL during the time that 40 kilohertz is, we assume, going through ground to our receive signal. It goes back up high, and then let's see if we can, and it remains low here even after that signal has stopped, which we assume is the received signal propagating back and being locked in the phase lock loop.
Cool. This is what we have so far. This is what we will be turning in as proof as we are out of time for this Tuesday's presentation. Thank you for watching.